While they're doing that, you might copy the first, like example 1. We'll hold a string. Just like simple as well. Well,
you're gonna want to follow along though too. So
I need to go back and still watch that part of the video.
Yeah, definitely. Well, you might be able to figure it out once we go through the today. Okay, guys. Example 2. This is in lesson 4.3.2. Yesterday, we did example 1 at the top, yes. We kind of had 4 steps to follow. We talked about reference angle and all that. And now we're working on example 2. We did A before we left, which was sine of negative 210. We found the reference angle. We found that it was 30 degrees from the x-axis. We found the sine of 30 to be 1/2, and in quadrant 2, it's positive. So, brief synopsis there. I want to look at cosine of 240. So, cosine of 240. I'm referring to these unit circles a lot today. I keep holding mine up. What do you know about 240?
It's in the third. It's in the fourth. Yeah, that.
It's in the third quadrant because it's after you pass 180 and before you get to 270, correct? So 240 is in quadrant 3. And I want to know how far is 240 from the x-axis. So here's my x-axis, right? How far is 240 from the x-axis? What am I going to do to find that?
240 minus 180.
Okay, because this side of my x-axis is 180, right? So we're trying to figure out how far 240 is from 180. So we're going to subtract.
Do you take the bigger number?
Bigger minus smaller, right?
Okay, I didn't know.
Sometimes it'll be the angle minus 180. Sometimes it'll be 180 minus the angle. Just be logical about it. Bigger minus smaller. So 240 minus 180 is 60 degrees. So this 240, it is 60 degrees from the closest portion of the x-axis, right? So then what are we asking ourselves? What is the cosine of 60 degrees in quadrant 3? So how do we find the cosine of 60 degrees?
Look at your chart.
Look at your chart, yes? Just I have to say that just to remind us that we had that chart back in 4.2 somewhere, right? Okay. So in our chart, the cosine of 60 is 1/2. And then what do we know?
It's negative.
All students take calculus. We're in quadrant 3 here, yes? What's the T say? Tangent is positive. That means sine and cosine are going to be negative. So, quadrant 3, what do we know about cosine down quadrant 3?
Negative.
It's negative. So this is actually a negative 1/2 because we are finding the cosine down in quadrant 3. Questions on that, Carter?
So if we after we've subtracted our angle from the closest side, if we don't get 30, 45, or 60, we've done something wrong.
Probably.
Okay.
If it's designed where you're supposed to get one of those 3 reference angles, then yes.
There are ones that are designed where
In this, I mean, technically we could, we could do cosine, sine, tangent of any random angle. So, technically we can, but for what we're doing here, like in this section, this A through F, sorry, don't ask, A through F, then you should always be getting a 30, a 60, or a 90.
Okay.
Or pi over 6, pi over 4, pi over 3.
Right.
Okay? Okay, so let's look at B now, since I do not know my alphabet. Tangent of 5 pi over 3.
The fourth quadrant.
If you want to just go straight to your unit circle, you possibly could, right? 5 pi over 3 is down there in quadrant 4, correct? And so we want to know,
Pardon the interruption. Gabe Rodriguez, would you please come to the middle school office? Gabe Rodriguez, please come to the middle school office.
okay, 5 pi over 3 is down here in quadrant 4. How far is 5 pi over 3 from my x-axis? So where is it closest to the x-axis?
To the 2 pi.
At the 0, 360, 2 pi, right? All three of those are correct answers, but we really need to think 360 or 2 pi. Because we're in radians, we need to talk 2 pi. So in order to find out how far apart 5 pi over 3 and 2 pi are, we need to subtract those. And so in order to subtract those, I mean, technically we say 2 pi,
Or 6.
but we need to think common denominators, right? So when I say 2 pi minus 5 pi over 3, it's really going to end up being 6 pi over 3 minus 5 pi over 3. And that's because this was 2 pi, correct? So 6 pi over 3 minus 5 pi over 3 is 1 pi over
Pardon the
3.
interruption again. Shelby Pickett, would you please come to the middle school office? Shelby Pickett, please come to the middle school office.
Sounds like a good day down in that office right now.
So unhappy. So
Well.
very interesting.
If they've interrupted us twice, it's definitely not a good thing. Okay,
Why do they go on the announcements sometimes, and why don't they just call them? Like,
Because
they
if
can't
there's a
find them.
call-
they're not in class.
Alright,
If they're calling them, they're not where they're supposed to be.
gotcha.
Guaranteed. Don't know where they're at. Obviously, you know. Were they maybe just late leaving the previous class and still there? Always a possibility. Are they out gallivanting somewhere? Always another possibility.
Gabe had,
So, huh?
Gabe had lunch, I know that. See them at work.
Okay. So, did you guys follow here? Tangent of 5 pi over 3 becomes tangent of pi over 3 in quadrant 4. So, what is the tangent of pi over 3 in quadrant 4? Well, wait. Let me ask. What is the tangent? You're right. What is the tangent of pi over 3?
Square root of 30.
And how do you know it's square root of 3?
Because of the chart.
It's on our chart, right? That, go back to like lesson 4.2. That chart we created that you're going to have to memorize and quiz over next week?
Next week.
Probably. I haven't done my lesson plans, but that's my guess. It's 4, exactly. Memorize the triangles. Let's see. That chart was, hey,
4.2.2.
4.2.2. I got another set too.
I want to say I'm done with these.
Okay.
I'm done with the first part.
Yeah. So 4.2.2, right? That's the chart I'm talking about. That's the chart you're going to have to memorize and reproduce on the quiz next week. So, with that in mind, if you look right there, it says tangent of pi over 3 is square root of 3. Now, what quadrant are we in?
Before.
Quadrant 4. What do we know about tangent in quadrant 4?
It's negative.
It's negative. Because the C says cosine is positive,
Everything else.
everything else is negative. So sine and tangent are negative. So this is a negative square root of 3. Okay. Questions there?
Where did we get the 6 pi over 3 from?
Because that is equivalent to 2 pi, but with a common denominator of 5 pi of the 5 pi over 3.
Oh, okay.
In other words, technically what I'm doing here is 2 pi minus 5 pi over 3.
Okay.
But 2 pi is 2 over 1, which then can become 6 over 3 so that I can subtract.
Okay, I see.
Okay? Okay. E. cotangent of 19 pi over 6.
Can we, actually, go ahead.
What are your thoughts about 19 pi over 6?
Okay, now I'll say it. Can we, take this 6 pi over 3 and make it, 12 pi over 6?
Okay. 19 pi over 6 is big, right? That's what I see. When I look at that, I'm like, that's big. And is 19 pi over 6 on my basic unit circle? No. So do we know, maybe some of you figured out, but do you know exactly where 19 pi over 6 lands? No, not really. I don't know what quadrant that lands in. And so I want to simplify it. Vocabulary, we're going to find a coterminal angle. So another name for that angle, which means we can subtract 2 pi, right? You can always add or subtract 2 pi to find other names. If we subtract 2 pi, life should be better. Now, let's see. So we're going to do 19 pi over 6, and I'm going to subtract 2 pi.
Like 2 pi or pi over 2?
2 pi, because what is once around the unit circle?
Okay, 2 pi.
2 pi, right? I'm subtracting 2 pi because I'm trying to take off a revolution. So when I take off 2 pi, we're going to take off 12 pi over 6, right? And I only did 12 pi over 6 because I need that common denominator. What is 19 pi over 6 minus 12 pi over 6? 7 pi over 6? I don't know about you guys, but that's a little bit better. Can you figure out where 7 pi over 6 lands? I can because I know it's a little bit past pi. I know 7 pi over 6 is a little bit bigger than 1 pi. So I know it's going to land in quadrant 3. Now, is 7 pi over 6 one of our reference angles on our chart?
Yeah.
7 pi over 6 isn't.
Oh.
But I want to know, how far is 7 pi over 6 from the x-axis? So what do I do to figure out how far it is from the x-axis?
Pi minus.
You subtract pi.
Yeah.
So we're going to take 7 pi over 6. And now we're subtracting 1 pi. Because it's not about trying to make it smaller or bigger. It's about how far is it from the x-axis. And if that x-axis is 1 pi, which what do I want to use for 1 pi? 6 pi over 6. 7 pi over 6 minus 6 pi over 6 is pi over 6. So that means I'm going to actually be doing the cotangent of pi over 6, but in quadrant 3. Now, I don't know what you guys prefer. You can think cotangent if you want. Or what do you know about cotangent?
It's just the opposite of tangent.
It's the reciprocal of tangent, yes? So you can either think cotangent, or if you prefer, you can say, okay, it's the reciprocal of tangent. However that may, whichever makes you happy there. And you can just write cotangent pi over 6. You don't have to write that tangent pi over 6 to the negative 1 if you don't want to. So which way do I want to ask this? What is the tangent of pi over 6?
The square root of 3 over 3.
That's the square root of 3 over 3. So then the reciprocal of that,
3 over square root.
3 over square root of 3, but the better form of that is just square root of 3. And keep in mind, when we filled out that chart, before we had square root of 3 over 3 for tangent, we had 1 over square root of 3. Hopefully you wrote that down so you can visualize it. And the reciprocal of 1 over square root of 3 is square root of 3 over 1, or in other words, square root of 3. Okay? Negative or positive square root of 3?
Positive. Oh, probably not, actually. I don't know.
I think 1 and 3.
Well, now I've heard both.
It's
Only positive
positive.
because it's in
No, it is
quadrant
positive.
3.
Yeah. Okay.
See,
Okay. So, quadrant 3 is our T quadrant. So that means tangent and cotangent are
positive.
positive. Sine and cosine would be negative. So this is actually positive square root of 3.
I was thinking it was
What problem do I need to solve?
Where did we go after pi over 6? Oh, I got that.
Here?
Yeah.
I put it up here and I said, okay, so we're doing the cotangent of pi over 6
Okay.
in quadrant 3,
Yeah.
right? And then what I said here is, okay, it's cotangent of pi over 6, which is the reciprocal of tangent of pi over 6. So I wrote, and maybe this was a bad idea, could have been a bad move on my part, always possible. I wrote tangent of pi over 6 to the negative 1, indicating we're going to think reciprocal of tangent. Because I'll be honest, me as a math person, you ask me what secant, cosecant, or cotangent of something is, I'm going to go figure out what the sine, cosine, or tangent of it is, and then flip it. Okay, that's what that's what me. I don't have the whole big chart memorized where I know all 6 functions. I know my 3, and then I just use reciprocals to get the other 3. Does that make sense?
Yeah.
Okay. Question solved for the moment?
Yeah.
Okay. Well, let's try C. Secant of negative 3 pi over 4. Different people will do different things on this one. Some of you like negative 3 pi over 4. You don't care about negative. You can handle that. So if that's you, where is negative 3 pi over 4 take me? Takes me down, right? Remember, negative, instead of going counterclockwise, we go clockwise. And so if we're 1 pi over 4, 2 pi over 4, 3 pi over 4, negative 3 pi over 4 is in quadrant 3. So if you're at a place where your brain is okay with that, great. You can place negative 3 pi over 4 here in quadrant 3. If that's still a little confusing to you, can we come up with another name for negative 3 pi over 4 that will maybe you can find on the unit circle and make life better? How do we find another name for negative 3 pi over 4? We're going to add 2 pi. Because anytime we want to just find, okay, what is that with another name? We add or subtract 2 pi's. What form of 2 pi do I need on this one?
4 pi.
Not 4 pi over 4. 8 pi over 4. And negative 3 pi over 4 plus 8 pi over 4 is, because I'm trying to add 2 pi. Because I want to know, I personally can figure out negative 3 pi over 4 is down here. But some of you are, less likely to figure out the negatives. And so some of you would rather know what is it in positives, so you can find it on the unit circle easier. And so negative 3 pi over 4, if I add 2 pi, that takes me one time around the circle and gives me another coterminal name for it. Okay? And so I know, if I start here, negative 3 pi over 4 is going to land me here. Some of you know that and understand that at this point. Some of you are still trying to figure that all out. So I need another name for it, which means if I take negative 3 pi over 4, and I add 2 pi to it. Remember, 2 pi is once around the circle, yes? So if I add 2 pi, it's going to take me back around, but it's going to give me a positive value. It's going to give me this 5 pi over 4, which makes more sense to a lot of you. Am I making sense? Kind of.
I just don't see where the 8 pi comes.
Because that's the equivalent of what's 2 pi as a fraction? 2 pi over 1. And then I need the common denominator of 4.
Oh, okay.
Is that the part I need to?
On the denominator, yeah, that part.
Okay, there's what I need to say. So it's 2 pi over 1. And then if I multiply top and bottom by 4, 2 times 4 makes it 8. Okay? So now, are you confident on where 5 pi over 4 is? No excuses, it's on the unit circle, right? But my brain also says, oh, 5 pi over 4, that's a little bit bigger than 1 pi, right? It's a little bit bigger than 4 pi over 4. So, let's see, we did say what? Quadrant 3. Already forgotten, geez. I need a reference angle. How far is 5 pi over 4 from the x-axis? Where is it closest to the x-axis? Over here at pi. So that means I need to do 5 pi over 4, and I need to subtract 1 pi. But I need 1 pi as a fraction with a common denominator. Yeah. I mean, if you think it's pi over 1, so then we're going to make it 4 pi over 4. And 5 pi over 4 minus 4 pi over 4 is 1 pi over 4. Oh, guess what? That just so happens to be on our chart, doesn't it? Magical coincidence every time, guys. So what are we asking ourselves to do this problem? What is the secant of pi over 4 in quadrant 3? Or what is the reciprocal of cosine of pi over 4 in quadrant 3? So if you're looking at a chart, you can just go straight to secant of pi over 4 if you want. Or, as I said, what my brain does is I say, okay, what's the cosine of pi over 4? Well, it's square root of 2 over 2. But I know I have to do the reciprocal, so I'm going to backtrack and say, okay, it's 1 over square root of 2. What's the reciprocal of 1 over square root of 2? Square root of 2. It's also straight on your chart, isn't it?
Yeah.
Go back to that chart if you prefer. Is this positive or negative? Negative?
Yeah.
Okay. We're in quadrant 3. Tangent's positive here, but sine and cosine are negative. Secant is the reciprocal of cosine, thus it is negative. Are we making any progress here? The radians are probably the hardest, I get it. There's not, but this is why I say don't just back off and say, I'm not going to work with radians, I'm just always going to change it to degrees. That won't benefit you in the long run. Maybe short term it might, but long run, Okay, last one in this section. Cosecant of 495 degrees. I have one thought in my mind when I see 495 degrees. It's big, right? I don't know where 495 degrees is on this silly circle. Not a clue. So in order to figure out where it is on the circle, since it's big, I'm going to minus that 360. Get me a more workable number, I hope. Let's see. 495 minus 360. Does that do it? I don't even have to look at my unit circle for 135. 135 is going to be past 90, but before 180. Does that make sense to you? That's why I'm saying I don't look at the unit circle. I know it's going to be past 90 before 180, so I know that I'm working in quadrant 2. $135. If I'm in quadrant 2 over here, where is that closer to on the x-axis? That's closer to over here at 180, isn't it? So what do I do to find my reference angle? 180 minus 135. 180 minus 135 is 45. Magical coincidence? So I'm asking myself, what is the cosecant of 45 degrees in quadrant 2? My personal brain is thinking, what is the sine of 45 degrees? And then I'll reciprocal it. Okay. Ultimately, you get square root of 2 here. Your chart says the cosecant of 45 degrees is square root of 2. Or your chart says the sine of 45 is square root of 2 over 2. Which if I back up, it's 1 over square root of 2. And so the reciprocal, square root of 2. Positive or negative? What?
Positive.
Positive. Because we're talking cosecant, which is sine, basically. And in quadrant 2, sine is positive. So this is a positive square root of 2. We getting a little better?
Yes.
I mean, this is a big topic, and this is a topic that you have to know. It carries a long way. Through trig and pre-cal and calc, you know, this carries a lot. So it has to be one that we become more comfortable with. Yes, Jaden?
So, since sine of 45 is also, or you can say like 1 over square root of 2, square root of 2 over 2.
Mhm.
If you put 2 over square root of 2,
I prefer you rationalize it.
okay.
Because if I put,
Oh, yeah.
I mean, officially, if you go well, my brain said 2 square root of 2, but if I rationalize, multiply by square root of 2, then I get 2 square root of 2 over 2. And the 2's cancel, and you get square root of 2. Okay? Okay, now I talk about this bottom side. We need to make some understanding of it. And I think I can go ahead to next page. So I think I have this on the next page. Angles whose terminal side lie along one of the coordinate axes are what we call quadrantal angles. You actually had a little experience with quadrantal angles in your last homework. Remember 9 and 10, where I drew these imaginary triangles? I made a real triangle, but it wasn't really realistic because I gave it a side length of 0.
Yep.
And I said, okay, this is kind of like, I'm just trying to get you to visualize it. Well, here's a better way to be able to do those types of problems. Okay? So, these do not produce reference angles, so we have a special way of finding them based on the unit circle. Okay, this is already kind of on your unit circle, but in an ordered pair on the unit circle, now keep in mind, this is called a unit circle, as in the radius is 1 unit. If you notice here, going out from the center to any of the edges on the axes, it goes out up or down 1, doesn't it? So on the unit circle where the radius is 1, the x value is always the cosine value. So x is cosine, and the y value is always the sine value. And everything can be found based on these. Okay? So, in an ordered pair, it's cosine, sine. So in an ordered pair, xy, It's cosine, then sine. Did you guys, on the unit circle I gave you separately, what do I have written over by the x-axis? Cosine. What do I have written up by the y-axis? Sine. Okay, so that's kind of your, I put that on there to try and help. So, based on that, if you're looking for the sine of an angle, you're looking for the y value. If you're looking for a cosine of an angle, you're looking for the x value. If you're looking for tangent, well, tangent is actually equivalent to sine divided by cosine. And so tangent is y divided by x. If you know what's in this bubble, these quadrantal angles are going to be a piece of cake now. We don't have to worry about trying to draw an imaginary triangle. We can use our x and y values. Okay? Let's look at one and I'll explain as we go here. So sine of negative 270. Well, big deal. We've got to know where is negative 270. Thoughts?
The y-axis of the top.
Okay. She says y-axis on the top. Does that make sense? Because if I start here and I go around, negative 270 puts me up here in the same spot as 90. Now, the other option, if you prefer, could you add 360 to officially change it? I mean, if you're one of those, you're like, nope, I'm not working with negatives. Just add that 360 every time. Negative 270 plus 360 is, hey, guess what? 90. So in order to do this, yes, we're thinking, what is the sine of 90 degrees? Okay. On the y-axis, how far left or right do you go to go up the y-axis? You go 0 left or right. And then if we're talking unit circle, we're going to go up 1. So like right here, to get to 90 degrees, you're going to go left to right 0 and up 1. So the ordered pair that represents right here is the ordered pair 0, 1. Well, what did we say sine is?
Y.
Sine is the y value. What's the y value in this ordered pair? 1. So what's the sine of 90 degrees? 1. Okay. This is where I tried to draw that fictitious triangle yesterday, where I drew a physical side length of 0, and then up 1, and then we could still end up with the radius 1. Same idea, but you don't have to actually draw the triangle. Are we okay with this one?
When did we do this?
On 9 and 10, in the last homework, like 9 was the ordered pair 5, 0. And so yesterday when I was going over homework questions, I drew an angle or a triangle with a side length 0 and a side length 5.
So when it lies on
Oh, so yeah, so we're using this when it lies on an x or y axis. Sorry, I didn't understand the question there.
How do we know we go up 1?
Because it's a unit circle, and a unit circle has a radius of 1. Unit as in being 1 unit. Okay?
I'll just.
Okay, let's try another one. Tangent of 3 pi. Biggest deal on these is you've got to be able to figure out where is 3 pi. Where's 3 pi? What's end up being the same as?
180.
180 or 1 pi, right? If you are all about the subtracting, 3 pi minus 2 pi is 1 pi, correct? And where is 1 pi? That's over here, yes? What's the ordered pair that represents that left side?
1.
You would go left 1, up or down 0. So the ordered pair is -1, 0. What am I being asked to find? It was tangent of 3 pi, or in other words, tangent of pi. What is the tangent?
-0 over 1.
Okay. Y divided by x. Y is 0. X is -1. What is 0 divided by -1?
0.
Or let me rephrase. What is 0 divided by anything?
0.
0.
Say like we had like a crazy like tangent of 50. We can multiply that 2 by any number to get it to where we think it'll be. You know what I'm saying?
Basically, yeah. Basically, your odd pi's are going to be equal to 1 pi.
Right.
Your even pi's are going to be equal to 2 pi or 0.
Yes, but I mean, I was just saying, like, for,
Yeah.
on 360, say we have an angle of -1020 or something. We can.
He's going big, but yeah.
Okay.
Okay, secant. And this is just supposed to say secant of 11 pi over 2, and that's what your notes say, I think. There's random negatives, I think, that scanned in there somehow. They're streaks, really. Okay, 11 pi over 2. Well, you know what I think when I see 11 pi over 2?
Wow, that's so large.
It's big. I don't know where 11 pi over 2 is. I've got a 50-50 shot, though. I know it's either going to be pi over 2 or 3 pi over 2, but that 50-50 shot means I also have a halfway chance of getting it wrong. So, if it's big, what am I going to say we do?
Subtract.
Subtract what?
4 pi over 2.
Okay, the equivalence of 2 pi, right? Because it's too big, we want to take off a loop around the circle. So I'm going to subtract 4 pi over 2. 11 pi over 2 minus 4 pi over 2 is 7 pi over 2. Still too big. So what do we do again?
Subtract it again.
Subtract it again. Add or subtract. This is what Carter was just talking about. Add or subtract however many 2 pi's you need to. So I'm going to subtract another 2 pi, which is 4 pi over 2. 7 pi over 2 minus 4 pi over 2. 3 pi over 2. Hey, now I know where I'm at. Okay? So, I'm asking myself, what is the secant of 3 pi over 2? Where is 3 pi over 2? That's 270, isn't it? What is that ordered pair down there? From the origin, you go left or right, 0, and down 1. So that represents the ordered pair 0, -1. Okay, secant. What do you know about secant?
It's the reciprocal of.
It's the reciprocal of cosine. Okay. So what would cosine of 3 pi over 2 be? Zero. But I'm going to have to do the reciprocal of it. So what's 0 as a fraction? 0 over 1. So what's the reciprocal of 0 over 1?
1.
1 over 0, which is undefined. Remember we talked about that yesterday, didn't we?
How did we know that it was 0?
Because, so the cosine of 3 pi over 2 is 0, because that's the x-coordinate. Cosine is x. So the cosine of 3 pi over 2 is 0. The reciprocal of 0 ultimately is undefined. Okay? I would just flat out memorize that.
You know, these, we really aren't looking for, like, we can't finish the problem with cotangent, cosecant, or,
You can, depending.
Okay.
I mean, because I can look at secant. Well, yeah. I mean, I'm still gonna have to think. Okay, cosine. What's the? I do have to still coordinate there. Let's jump down to f real quick, if I have a moment. Where's negative pi over 2? That's gonna be down here. Yes. So we're really asking ourselves for the cotangent of 3 pi over 2 if you want, which means I really need the reciprocal of tangent. Now, what's the ordered pair down here? Well, same one we just had, left to right 0, down 1. How do we do tangent?
Y over X.
Y over x. So what am I going to do for cotangent? X over y. And so x over y is going to be 0 over negative 1 or 0. Okay, the plan. I pretty much did the front page, right? There's a little bit on the back page I didn't get to. I think I will most likely record the back page tonight. Your plan for tomorrow in class. Get any notes you've missed. And then page 347, 21 to 48. And this is all due Monday. Be working. Okay? Use tomorrow for math time. This is your best time to work on math because even though for the most part once you end up working individually, you can still, you're here to help each other, right? So.
I made that.